So in class, we talked about different kinds of watersheds and we tested out how quickly water soaked in on different kinds of surfaces. So, what does that mean when we put those two ideas together? When we look at watersheds and what kind of land use we have on them. So this goes along with page 220 and 221 in your book. You might be able to see the pictures better in your book than in this video. So you might want to follow along as we go. So we have three maps, and this is some pretend maps, not a real region, but we can look at maps like this and determine what kinds of land use maps have. So you're going to look at three maps of the same area over 100 years, and I want you to pay attention and see how the land use has changed over the last 100 years. And you can see the key, and these maps are coded with forest, wetland, grasslands, residential, agriculture, and river. And if you have your book, the pages are 222, 223, and 224 in your book for the maps. So here is our map, first map of 100 years ago. And then here are maps B of 50 years ago and map C today. You might need to rewind this video if you don't have your maps in front of you, but what happens to the amount of forests between map A and map C? Which map has the most land devoted to human settlement? So, according to the directions for this activity, it says to determine the land area of each of the maps, and then we want to determine how much area is occupied by each type of land. I'm just going to skip straight to the answers. If you counted, the total land area is 360 kilometers squared because each square is a kilometer squared. If we convert that to meters squared, that's 360 million meters squared. And you can see the different kinds of land coverage on each map. Now, we're going to come back to those different land coverage numbers in a second, but let's suppose that whatever this area is, this 360 kilometers squared area, which, by the way, I looked it up. It's smaller than Campbell County, but bigger than Lynchburg City. So this map is on the order of a small county. Maybe even like the Lynchburg metropolitan area, if there is such a thing. So like Lynchburg out to Forest, maybe Madison Heights, Lynchburg and its outskirts. So that's the size area that we're talking about. Let's suppose that this area gets 5 centimeters of rain. 5 centimeters is about 2 inches. 2 inches is a good amount of rain. Like, it's a lot of rain, but it's not unheard of. Like, we just got 2 inches of rain or more a few days ago. So let's suppose that our area gets 5 centimeters of rain. How much rain is that? How much water has hit our watershed? So we would just have to do some math. We would take, making sure everything's in the same units, we would take our 0.05 meters and multiply it by our 360 million square meters, and we would get 18 million cubic meters of water hit our watershed. How much is a cubic meter? So you know a meter stick, those long rulers? Imagine having 1 meter stick in one direction, 1 meter stick in another direction, and another meter stick in the third direction to make a box and fill 18 million of those with water. Another way to think of it, I've heard that a mattress, like a twin size mattress, is about the size of a square meter. So that's how much water has fallen. And again, remember, this is not an unusual rainstorm. It's like a solid rainy day. How much water has hit all of the places in our watershed? And what happens? So, in our next table, which is already filled in on page 221 for you in your book. What this has done is we've taken this 18 million cubic meters of water, and based on how much forest and how much grassland and how much wetland and how much residential and how much agriculture, it has been spread out that it's gotten the appropriate amount of water hitting it just by dividing it in its percentage. Hopefully, you've seen, though, that different kinds of ground absorb water differently. So, different kinds of ground are going to have different amounts of runoff because if it doesn't absorb, if it doesn't percolate into the ground, then it's going to run off. So, we also have in this chart numbers of percent runoff. So for the forest only gives us 10% runoff. Grassland 20, wetlands only 5, residential 90%, agriculture 30%. So we take the volume of water that hits the forest, for example, and 10% of that runs off. So that means that we get 945,000 cubic meters of water running off. And so we've done the calculations for each of those, add up all of our runoff, and we get just under 2 million cubic meters of water running off. This adds into the stream because the water that's going to directly hit the river is going to add to the river, and that's 5.5 million cubic meters. So we get that much of the stream. And so we can see our total runoff plus our addition to our stream. Now compare map A to map B to map C and see what happens over the different years. So looking at our questions, it says which absorbs more water, concrete or forest, or wetlands, or grasslands? And which map represents the watershed that is able to capture and store the most water? Now, here are some thinking questions for you. What problems could arise if water quickly runs over the surface instead of moving slowly or soaking in? Hopefully, you might have had some ideas like erosion or soil washing into streams or pollution getting washed in. Trash can get washed in. So, any of these fast runoffs, they're just going to increase the amount of stuff that flows into our streams. So, a follow up question: how might the water quality of the river be affected by changes in the watershed? So, if we have this increased erosion or just pollution running off, or even increased flooding because we get lots more runoff and then uh, during a rainstorm, if you see, we get almost, well, more than double our total runoff here between map A and map C. That's just a lot more water for every rainstorm. So that could lead to flooding, and flooding can cause all sorts of problems with just the stream and even the surrounding houses or other land around the stream. So it can definitely affect our quality of water. So this was a example Let's see what it looks like in real life. So I've switched now to a website that you can actually go to and explore and play around with. This is Lynchburg's GIS site, and it has all sorts of information about all of the properties in Lynchburg. And one of the rules is that they have to take photographs every year or so, aerial photography of the entire city. So here, perhaps you recognize what we're looking at right now. So here you've got College Lake and the Dell, and we've got Lakeside Drive and Old Forest Road. So this is our campus and the surroundings. Let me turn off property information. Yes, so I just want the map. So here we've got College Lake, and this is our most recent imagery from 2019. So let's go back in time because we can go way back. Let's go back as early as the imagery that they have loaded into the website that they have. This is 1941. Black and white, yes, but hopefully you can notice something about College Lake. Look at the size of College Lake in 1941 compared to now. So what's happened? And we can even do it in little steps. So there was 1941. You can also see less is on campus at this point. Let's zoom ahead to 1972. Already in 1972, this part here is not as much of a lake as it was. There's more campus as well. 97, we've lost all of this lower part of the lake. And maybe you can even see that there are some dark areas in the lake that actually are shallow areas. That's not loading totally. Let's pick a different year. There's 2003. You can almost see like a sandbar here. 2015, this whole back area of the lake is islands. And we get to today. What is happening to College Lake? Now let's talk about why. So College Lake is formed by a dam. It's along Lakeside Drive. So Lakeside Drive actually drives right over the dam. You might have even heard of this because it is some local news that they are actually going to have to get rid of the dam. It has been damaged. I believe it was 2 years ago in August. There was a storm that 8 inches of rain fell over part of Lynchburg, and there was big flood, and it really affected College Lake. College Lake spilled over Lakeside Drive, actually. It ended up damaging the dam here that forms College Lake. And so the dam, which was older and needing to work anyway, has been slated for removal, which means that College Lake won't be a lake anymore. But is it really being a lake right now? Most of it is very shallow, and you can see that it's filling in. It is shrinking every year and getting shallower and shallower. And so naturally, it wouldn't be a lake very soon. So instead, they're looking at turning it into a wetland. But I'm getting a little ahead of myself. Why is there a problem with College Lake? So let's look. I'm going to zoom out a little bit. So here we are in Lynchburg, zooming out, and I'm going to look over here. Why am I looking over here? Because the water is headed in this direction. So the water comes into College Lake from this direction and then heads out. So I'm going to head this way. And I'm going to zoom back in. And let me get rid of my property labels. So this is Windhurst. And this is the Jamerson Y. Maybe you are familiar with that. And this is the Windhurst development here. So let's look at what this looked like back in 1941. Although I'm not sure we've got good footage. There we go. What do you notice? What kind of land is Windhurst in 1941? Even check it out in 1997. So I guess I should step through it a little bit. So sometime between 1997 and 2015, we get Windhurst. So if we look back, (2001), the road starts to be built. 2002, the Jamerson Y is completed, but nothing else is built over here yet. 2003, they start construction on different houses, townhouses, the Summit. 2006, we get the vast majority of Windhurst. But this is all relatively recent that we have totally developed this area. How about another nearby area? So we're going to go back to today. You can see all of the I should have attached my mouse to my computer. So let's cross Timberlake Road. Here's Lowe's. Here's Brookville. Come over here, and we see Cornerstone, where the new tea room is, Iron and Ale. Let's check out 1941. Again, what was this in 1941? (1997), the farmhouse was still there from the farm that was. Still there. There is some development across the street, some apartments. Still the farmhouse, 2003. (2007), you can see construction beginning. They actually moved the farmhouse. And then buildings being built, 2011, 2015. And if I scoot over a little bit, just to get another view, up here's Timberlake Road, here's Cornerstone. So that was 2015. 2017. 2019, but maybe you know that this doesn't even look like this today. If you were to drive down Timberlake Road, these are all buildings being built at this point. I think Sheets is going in over there, apartments. So building is still continuing in this area. So what happened? We went from forests and grasses or maybe agriculture land to residential. And what does that mean for the amount of runoff that's happening in this area of Lynchburg? And with that increased runoff, which is going to travel in this direction, what does that mean for College Lake? It means that all of that runoff is going to have increased erosion, which is going to bring sediment, and it's going to be filling in our College Lake because the dam slows the water down and the sediment drops out of the water. So this week's discussion is actually about the College Lake problem, the discussion and debate about what's happening to College Lake, because it's making some local news and information about what's going to happen. So hopefully use your new knowledge of watersheds and land use to become better informed about this very important issue that affects both the university, who owns the land that College Lake is on, and the city of Lynchburg, who owns the dam and the road that crosses it.